Hello class, today we're going to talk about the Pythagorean Theorem. Now if you recall, the Pythagorean Theorem is only applicable to a right-angled triangle. How we can distinguish a right-angled triangle is by looking for the square in one of the angles. This square indicates that this angle is exactly 9 degrees. Now there's one other special characteristic of a right-angled triangle, and that is the hypotenuse. The hypotenuse is the side that is opposite to the 9 degrees. And this hypotenuse tells us the length of the side. So now that we know the hypotenuse, we can go into the Pythagorean Theorem. So the Pythagorean Theorem came about over 2,500 years ago when a Greek mathematician named Pythagoras of Samos discovered a special relationship that exists between the lengths of the side of a right-angled triangle. He stated that the sum of the areas of the squares on the legs of the right-angled triangle is equal to the area of the square on the hypotenuse. So now there's one other term that we haven't defined yet, and that is this legs of the right-angled triangle. The legs are the other side lengths that is not the hypotenuse. So in our triangle here, we have this one side length, which we can call A, and that's one of the leg of the triangle. And we have this other side length, which we can determine as B, and that is also another leg of the right-angled triangle. So his statement says the sum of the areas of the squares of the legs. So here's a diagram which shows the area of the squares of the legs. Here is one of the legs. This is the side A we determined. And in this example, it's a 4 square length. Now the square of this side length is a 4 by 4 square, which means there are 16 squares in total of this square of the side. The other side B here has 3 squares, so the square of a 3 square length square is a 3 by 3, which is equal to 9. So his statement says that the sum of the areas of the square on the legs of the right-angled triangle is equal to the area of the square on the hypotenuse. So here is the hypotenuse again. It is opposite to the 9 degrees that would be here on the right-angled triangle. And we typically label this side length C. Now this C square in this example has 5 square lengths. So the square would be a 5 by 5. And that would give me 25. So according to Pythagoras, if I take the sum of the two squares, so side length A squared, which is a 4 squared, which is 16, and I add that to my side length B squared, which was 3 squared, which is 9, I should get my C squared, my hypotenuse, which gives me 5 squared, which should be 25. And looking at the side lengths, 16 plus 9 does give me my 25. We will typically see this Pythagorean theorem written as C squared equals A squared plus B squared. Now, it doesn't matter if you see it this way or you see it this way, they're the same equation. Okay? So you're going to be using this Pythagorean theorem today to find different side lengths, whether that is the hypotenuse side or the two other leg sides.